We know that a SIP request comprises three parts: a start line at the top, an optional message body at the bottom, and a selection of SIP headers in between. We've already looked in detail at the start line and the message body, so over the next modules we'll be studying the core SIP headers. Now there are lots of them to learn about, so it helps to remember that most core headers fall into one of four categories. They either associate different messages in a call and ensure they're correctly sequenced, describe the payload, identify the caller and the callee, or they contain routing information. We'll look now at the first category, specifically at the Call ID header. By the time you've mastered this module, you'll be able to describe the purpose of the Call ID, understand its construct, and use it to identify messages in a log. I've just restarted my two user agents, that's how we clear the logs, and I'll make a call from Alice to Bob. Accept and hang up, and I'll make a second call. Accept and hang up, and I'll go straight over and open Alice's log to study the Call ID headers in all 14 messages of the two calls. In fact, if you have your user agents handy, why not fire them up and make two calls of your own? Open Alice's log and take a look at the Call ID headers for yourself. While you're at it, look for a rule that describes the purpose of the Call ID. Go ahead and press play when you're ready and we'll discuss our findings together. Okay, here's Alice's log. Here's the first message, the invite request, and here's the Call ID header. You'll notice that it's made of a random string. In fact, it's a globally unique identifier, and that it includes the IP address of the caller. Now, note that the IP address is for uniqueness only, an optional extra to ensure that no other UA uses the same random number. It's never ever used for routing. Scrolling down to the 100 trying and the Call ID there, I see it's the same random string and the same IP address. In fact, as I scroll through the log, all of the Call ID headers are the same until I get to the second call. Here in the second call's invite and in all of these second call's messages, we see a different identifier. The Call ID does what it says on the tin. It's a unique call identifier. All the messages in a call are identified by the same Call ID. Each and every call has its own unique identifier. 1122 for this call, 8877 for this call. The Call ID being copied into every SIP message within each call. Now, Call IDs become even more relevant when considering servers in the core. A request is received and proxied, as is the response, each of the four messages being written to the server log. A moment later, another request arrives from another user agent and four more messages are written to the log. Now, both calls will likely issue further requests during the call, possibly even at the same time. With potentially thousands of calls every second, log files can very quickly become onerous and difficult to read. Knowing that each message contains a Call ID that's unique to its call, the task of identifying and filtering messages that belong to a call suddenly becomes easy. This request and this response belong to call 1234, and this request and this response to call 4455. So, the Call ID, a unique string that identifies each call. It's copied into each request and each response within that call. And it's the means through which we can sort through logs and filter the messages of the call that we're interested in. It may include the caller's IP address, although only for added uniqueness and never for routing.